Greetings, fellow scientists. My name is Jesse, and I'm a member of the Saskatchewan Science Center's Go Science Outreach Team. Today, we are going to have your mind blown as we talk about nuclear fusion and the sun. I have a feeling that this video is going to definitely end with a bang. Now, the sun is something that we're all very familiar with. Its rays help plants grow, it keeps us warm, it's at the very center of our solar system. But do you know what the sun is made out of? Well, it's a little bit of a tricky question, and it's also kind of complicated, but let's explore it together. Now, the sun is made out of gas. No, not like the gas that you pass, not that one, but like the air that's all around us. The air that we breathe is made out of oxygen and some other gases as well. While we can't see the air we breathe, we can certainly feel it. For example, if it's windy outside, or do this, put your hands in front of you and wave them back and forth like that, you can really feel the wind that's given off by that, and you can feel that air around you. In space, there is no air, and this is why astronauts need to wear special spacesuits with oxygen tanks attached to them when they go out to do spacewalks. So, I said earlier that the sun was made out of gas, but it's not the same kind of gas like the air that we breathe. The sun is a combination of helium, hydrogen, and a variety of other gases as well. But what do those have to do with nuclear fusion? Well, nuclear fusion is what happens when two hydrogen atoms combine together to make one helium atom. The reason that these hydrogen atoms combine is due to heat and gravity. Yes, gravity. The same force that holds us to the ground also pushes those atoms together in space. In fact, the combination of heat and gravity compress the hydrogen atoms together in order to form that one helium atom. Now, the amount of heat and gravitational force that's required for nuclear fusion is, well, out of this world. But we can show you what a combination of hydrogen and heat is like right here in the Science Center. In this balloon, I have a whole bunch of hydrogen gas. And in a moment, we're going to add some heat. And we know that we have gravity around us. Not as much as the sun, but gravity's working. I'm not floating away or anything like that. And we're going to see what happens when we combine some of those things together. First of all, let's put on some safety gear. All right. All right. 3, 2, 1. Wow! And that's kind of what nuclear fusion looks like. One thing to keep in mind, though, is that this balloon is actually very small, and the sun is really big. If we were actually to create nuclear fusion, the energy released would be extremely powerful. I'd need a lot more protective equipment than just this. Are you wondering why the sun doesn't make noise like that big explosion just did? Well, that's because, like we talked about before, there is no air in space. For sound to be able to travel to places, it actually needs to have air around it, or something to travel through. Since there's no air in space, there's no way for that sound to travel. Kind of weird, but also kind of cool. Well, we hope you were really blown away by this experiment. You can check out other neat experiments by visiting us online at sasksciencecenter.com. Until next time, stay curious, fellow scientists.
Hey, how you doing? Tommy Tungsten here for Elements R Us with another super special sale. We're all just pumped to offer you this sweet deal on iron today. Iron is a hard, brittle metal that is very important to pretty much all aspects of human life. As tough as iron is, though, we usually prefer to beef it up with a little bit of carbon and sometimes some other things to make it into steel, which folks use to make all sorts of useful things. You may have also noticed that over time, iron stuff starts to turn red and flaky. When oxygen in the air reacts with iron, the scientific term is oxidization, but most folks just call it rusting. That may be bad for your iron objects and all, but this is what makes it iron indispensable to your body. Ever wonder why our blood is red? That's right. Iron is used to make hemoglobin in your blood, And that oxidizing power is what lets us carry oxygen around our bodies to stay alive. Lucky for you, there's no need to break your teeth eating iron to get healthy. Many kinds of meat and a lot of those leafy green veggies like spinach are all packed with iron for your eating pleasure. So strike now while this deal is still hot. Come on down to Elements R Us and enrich yourself with some iron. And when you get there, tell them Tommy sent you. Capiche?
Hello everyone, my name is Sally Science, and I love it when you send in your curious questions for us to explore together. And today I have a blazing question from Liam. Good one, Sally.
How do stars glow?
What an illuminating question, Liam. Thanks so much for sending it in. When you look at the night sky, you see countless stars out there. But would you believe me if I told you that the star you are most familiar with is actually visible in the daytime? It's true. That's because our sun is actually a star. There are billions and billions of stars in the universe, and they come in a range of sizes. Our sun is a medium-sized star called a yellow dwarf star, and it glows so brightly for us because it is the closest star to Earth, only about 150 million kilometers away. Fun fact. Even though our sun is a medium-sized star compared to other stars in the universe, it is still humongous. Our sun is so large that you could fit 1 million Earths inside the sun. To really blow your mind, one of the largest stars in the whole universe is called VY Canis Majoris, and it can fit 9.3 billions of our suns into it, and it's not even the biggest star in the universe. How crazy is that? Okay, so to understand how a star glows, we need to talk about 3 things: gravity, atoms, and energy. A star is basically a big, bright ball of super hot gases, or plasma, as scientists call it, held together by gravity. Now, gravity is a force that is all around us, and it causes all things that have mass to be brought towards each other. The more mass something has, the stronger its gravity. So, you can imagine something as big as our sun has a lot of gravitational force holding it all together. Now, you can't see gravity directly, but you can see its effects. The Earth's gravity is constantly pulling you and everything else down towards the ground. Without it, you would float up into the sky like a balloon and drift off into space. When stars are born, gravity pulls together all kinds of dust and gases floating in space and compacts it closer and closer together, causing it to spin and become more dense. Imagine if you had a handful of some freshly fallen snow, and as you apply force with your hands, that force pushes all the snow tightly together to make a dense, compact snowball. And the force that you put on that snowball with your hands is kind of like what the force of gravity does to stars. Now, with a star, it takes a lot longer to compact than making a snowball. Eventually, after millions of years, the pressure of the gravity causes the star to heat up and eventually kickstarts a process deep within the heart of the star called nuclear fusion. You how I keep talking about those teeny tiny guys that you can't see called molecules? Well, would you believe me if I told you that those molecules are made up of even smaller teeny tiny things called atoms? It's true, and atoms are made up of even tinier things called protons and neutrons and electrons. Isn't that mind-blowing? Okay, so here's the real spark to answering your question, Niam. When a baby star or protostar gets big enough to start producing nuclear fusion energy, that means the pressure from the gravity is smashing all those atoms together with a lot of force, fusing the atoms together and causing a nuclear reaction. And that nuclear reaction creates a lot of heat, like millions of degrees of heat, and a lot of energy. And all that heat and energy fights its way out of the star to escape into space as light and heat through something called solar winds, giving stars their glow. And also, in the case of our star, the sun, giving us warmth on the earth that we need to live. How amazing is that? Thanks so much for this star-studded question, Niam. If you have a question that you would like to explore with me, please send it my way. I would love to hear it. Take care, friends, and I hope you all have some time to stargaze this week. This is Sally Science, signing off.